Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamed from Malaysia, Japan International Institute of Technology, UTM, Kuala Lumpur. I will presenting to you our paper entitled Redesigning the Sukhoi 30 MKM Aircraft Aerostatic Discharger. The author for this paper are Nadia Natasha Abdul Razak and Saluddin Muhammad from Faculty of Technology and Informatics Razak, UTM Kuala Lumpur, and Nur Shafina Marwa and me from Malaysia, Japan International Institute of Technology, UTM Kuala Lumpur. The main motivation for this project came from the high budget for the military purpose. So, for example, in 2021, there has been an increase for the military budget to 1.8%. That is about USD $3.84 billion. So, this high budget is necessary for most countries for their defense system. So, where this high budget goes to, part of that, this budget need to be used for the maintenance of the aircraft. For example, for Royal Malaysia Air Force, they have spent about 200 million just to increase the lifespan of the fighter aircraft to another 15 years. This has been reported by the New Straits Times. So where these 200 million ringgit need to be spent, one of that is just to maintain the aircraft aerostatic discharger. For this purpose, the amount that is required just to replace the AAD is approximately about 16,790 ringgit. This not include the operation and transportation costs. So what is aircraft aerostatic discharger or AED? So the function of AED is to discharge the charge that accumulate on the aircraft surface. So for example, for the civil aircraft, we can see this AED being placed along the trailing edge of the wing, where the charge of the aircraft being discharged to the surrounding air. There is also AED that been placed on the landing gear system of the aircraft. For example, for Sukhoi MKM, the AED is placed on the main landing gear of the aircraft. So when the aircraft landing, this AED will touch to the ground so that the aerostatic then being discharged to the ground. The main issue for maintenance of this AED is that to replace this AED for the Sukhoi MKM, the technician need to disassemble the wheel system of the fighter aircraft. So this required unnecessary tasks just to get this AED being removed. Therefore, we thought that we can simplify this process by redesigning the AED system. Therefore, for our project, the objective is to design a new compatible AED Sukhoi MKM that based on modular methodology design. Okay, so our aim is that this new AED can be directly been used by Sukhoi MKM, then be directly been applied by Royal Malaysia Air Force. So how we did this project, we we did this project by 3 consecutive phases. On the phase 1, we do document review where we look all the AED being used by the Royal Malaysia Air Force Fleet, and we also do literature review on the latest AED system. On the second phase, we do testing. This include the structure, temperature, and vibration analysis. And finally, we do a ground test where we can conduct the actual how much manpower been used and also the time required to do maintenance by this new proposed AED. Okay, so when we conduct the review on AED being used by RMF fleet, we found that most of the fighter aircraft, Hornet, Hawk, and Armory, they use bonding cable, and only MIG use static wick. And for helicopter, they use chain AED for EC725 and road AED for Nuri. So for specifically for Sukai MKM, this is the design where have been patented by the Tana aircraft. So it consists of carbon fabric at the end, and this rod need to be attached to the aircraft by this slot. So this is one system rigid of the AAD. So the technician need to replace all these part one set. So therefore, our proposal is that we instead of one set of AED system, we do two parts. One part is the bracket, where this bracket constantly or permanently been placed on the main landing gear, and the other one is the detachable AED. So the technician only need to replace the detachable AED. So this will reduce the cost and reduce the time when do the maintenance. And when we do the simulation on structural, temperature, and vibration, we found that there is no deformation on the physical structure of the AED. Only that when we increase the vibration up to 84.43 Hertz, there is the deformation on the weak stick. Okay, so this at very high vibration only. And the most important thing is to check the discharge capability, and our new design AED is comparable with the new OEM, very comparable and better than the existing installed AED. And when we compare the manpower and time, and the new proposed AED has reduced the manpower from 4 to 2, about half, and the time only about 240 seconds. Okay, so about less than 5 minutes. And for the cost, in actual, we need about 16,000. And for this new design, only 2,500. 1,000 for the bracket and 1,500 for the detachable work. Okay, so about one order of magnitude lower than the current AED. So in conclusion, we like to propose a new design of AED that's suitable for aircraft Sukhoi 30 MKM. And for this new design, we have two component, bracket and detachable wick. And when we do the structural analysis, there is no deformation, physical deformation been observed except at high frequency. And finally, we managed to reduce the time, manpower, and operating cost for the new AAD. Which that, thank you very much.